Assalamualaikum warahmatullahi wabarakatuh. My name is Wan Muhammad Arif Safwan bin Wan Aziz, student ID 2021483098. Schmidt rebound hammer and ultrasonic pulse velocity will be explained in detail in this video. The first equipment are Schmidt rebound hammer. A rebound hammer is a portable non-destructive testing instrument used to assess the compressive strength or hardness of concrete and other construction materials. It provides a quick and relatively simple method for evaluating the quality and uniformity of concrete structures in the field. The model of this equipment is NL4021X001. This is the cross-section of the rebound hammer, which includes a component plunger. Plunger is the movable part of the rebound hammer that is pressed against the concrete surface during testing. Spring is located inside the rebound hammer and provides the necessary force to compress the plunger against the concrete surface. Hammering mechanism is responsible for striking the plunger and causing it to impact the concrete surface. It may consist of a mechanical system or a spring-loaded mechanism that releases energy upon triggering. Trigger is a rebound hammer. Rebound hammer may have a trigger mechanism that needs to be engaged to initiate the impact of the plunger against the concrete surface. Rebound hammer can be used on the concrete surface, which is at a horizontal, vertical, or intermediate angle. The main application of Schmidt rebound hammer test on concrete can be listed here. For determining how hard concrete is, without causing any damage to the building, it is used to assess the compressive strength of concrete structure. It is used to locate the precise position of concrete weakest area. It's making repair work easier. The next one is procedure of rebound hammer. The first step is equipment preparation. Ensure that a rebound hammer device is in proper working condition. The second one is surface preparation. Clean the surface of the specimen to ensure the smoothness of the testing surface area. The next one is test point selection. Identify the area. A minimum of 9 test points were selected. Mark the test spots. The intersection of the line in a regular grid that is spaced 30 mm. After that is a testing procedure. Hold the rebound hammer firmly and perpendicular to the surface. Release the hammer and allow it to strike the surface. And lastly, observe the rebound distance on the scale as it rebounds. This number stands for rebound index. So the next one is the limitation of the rebound hammer. The first one is surface sensitivity. The surface conditions, such as roughness, can influence the rebound value. Irregular or rough surface may result in inconsistent rebound value, affecting the accuracy of the assessment. The second one is limited test area. The result may not represent the overall strength of large concrete elements or structures. The third one is operator skill and experience. Obtaining accurate and reliable result with a rebound hammer require a proper training, skill and experience. Standard and range of result. According to the standard data above 40 Nm² is a very good hard layer concrete. 30 to 40 Nm² is a good layer concrete. 20 to 30 is a fair. Below 20 is a poor concrete, and lastly 0 is delaminated. We move to the next equipment. UPV stands for ultrasonic pulse velocity. It is a non-destructive testing method used to assess the quality and integrity of concrete or other construction materials. UPV testing measures the time taken of ultrasonic pulse to travel through the material, providing information about its density, homogeneity, and potential defects. The next one is the component of UPV. The first one is the pulse generator unit. This is device that generates high voltage electrical pulse to energize the transmitter transducer. It also receives and amplifies the electrical signals from receiver transducer. The next one is transducer. Consists of piezoelectric crystals or elements that can generate and detect ultrasonic waves. One transducer acts as a transmitter to generate high-frequency pulse, while the other acts as a receiver to detect the pulse. The third one is calibration rods. To calibrate the UPV system, calibration rods are utilized. Since the ultrasonic velocity of these materials are well known, the calibration parameters and measurement accuracy are validated using their characteristics. The last one is coupling agent. Coupling gel is utilized to provide excellent acoustic contact between the transducer and the substance being examined. So the next one, we move to the procedure of ultrasonic pulse velocity. The first one is equipment preparation. Set up the ultrasonic transducer, wire and pulse generator or receiver device used for UPV testing. The next one is surface preparation. The surface of the substance being tested should be prepared. Surface must be cleaned from any dirt. The next one is surface marking. So identify the areas where the rebound hammer test needs to be performed. This place needs to be typical of the area being investigated. Measure 0.100 m for T1 and double it for T2, and a marker can be used to mark the test spot on the surface. Apply the coupling agent. In this study, we only use grease as a coupling agent since it is solely educational. Calibration. Place the calibration rod in the center of the transducer and perform a zero distance calibration to eliminate any time delay caused by transducer connection. Transducer placement. Position the ultrasonic transducer on the opposing sides of the specimen. Pulse transmission. The pulse generator or receiver equipment should be used to produce an ultrasonic pulse. The pulse frequency needs to be suitable for the substance being evaluated. Use the transmitter transducer to send the pulse into the material and the receiver transducer to pick up the ultrasonic pulse as it passes to the material. Distance measurement. Accurately measure the separation between the transmitter and receiver transducer. And finally, data analysis and interpretation. Analyze the recorded velocity measurement and contrast them with established standards or reference value. The next one is limitation of the equipment. The first one is influence of concrete condition. The condition of the concrete, such as surface roughness, moisture content, and the presence of coating or voids, can affect the transmission and reception of ultrasonic wave. The second one is limited depth of investigation. The depth of investigation is limited to a certain range, typically a few inches or centimeters for the surface. The third one is influence on reinforcement and aggregates. Reinforcement bars or enclosed aggregate present in reinforced or heavily textured concrete can affect the propagation of ultrasonic waves. And lastly is operator skill and equipment quality. The accuracy and reliability of UPV testing can depend on the skill and experience of the operator, as well as the quality and the calibration of the equipment used. The standard and range of result of UPV. In standard and range of result, we measure based on crack of depth. If more than 15 is excellent. If 12 to 15 is good. If 10 to 12 is doubtful. If 7 to 10 is poor and the below of 7 is very poor. So that's all from me. Thank you.